Welcome back, my math party people. I'm Anderson, your ASVAB coach, and we're here to ace the ASVAB as always. But the main issue that we're dealing with today, law of exponents. A lot of us don't know how to handle multiplying powers, dividing them, square roots of powers, all that stuff. What does that all mean? I got your back. So watch this video, so that way you can learn how to handle each and every single one of these different types of problems. That way you can feel confident and comfortable moving forward. And so if you'd like, click the link in the description of this video. That way you can get the problems that we're gonna do along with notes so you can follow along nice and easy. And as a reminder, we have a free practice test out now that includes video solutions to both math sections, paragraph comprehension, and explanations for word knowledge and general science. So go ahead, click the link in the description to go to the website. The practice test is included in there. That way you can raise your score and get the job you deserve. Let's go ahead and get started. And so again, here we are. Here's the first set of problems that we're gonna be taking care of. Again, you can pause the video here or click the link in the description. That way you can go to the website and get all of the notes that I'm gonna be going over. That way you don't have to stress out too much. But without further ado, let's go ahead and get started here. We have these 5 problems that we're gonna tackle one by one. Now, I'm gonna tell you right now, this one right here, probably the hardest one. So I'm gonna go ahead and kind of hop around to show you from start to finish how these different rules apply so you can really gain that confidence moving forward. So we're gonna start off with actually problem number 2. So I'm gonna come back to number 1, don't worry about it. I'll come back to number 1, but I do wanna warm you up and not lose you. So number 2 here, we have 2p squared multiplied by 3p squared. So here's how you wanna handle this. This is multiplying powers. When you're multiplying powers, all you need to do is add the exponents of the same variables. One more time, we're going to be adding the exponents of the same variables. So that p squared that you see right there and p squared there, that's going to become p to the power of 2 plus 2. So right over here, that's going to be, in green, p to the power of 2 plus 2. Now a lot of us are going to ask, okay, why do you actually add those exponents, right? And it's because you're doing this. When you look at p squared, really what you're doing is, hey, anything squared is that number times itself, right? It appears twice. So if you have 5 squared, 5 times 5. 10 squared, 10 times 10. P squared, p times p, right? And so that's essentially what you have, p times p. But if you have another p squared, think about it, my party people, you have p times p again. So if you have p squared multiplied by p squared, think about it. That's essentially going to be p times p times p times p. And so how many p's do we have? We have 4 total. We're going to add up the number of times it's being multiplied because that's going to give us p to the power of 4. So again, if you're on the website, make sure to click the link in the description to see these notes. That way you can really have a good time moving forward. But there it is. When it comes to multiplying powers, you add the exponents if they have the same variable or same base, same letter, however you want to say it. But there it is. And with the regular numbers out in front, the 2 right there and the 3 right there, those you just multiply as normal. So 2 times 3, that's going to give us 6. And so the answer here would be 6p to the power of 4. So again, multiplying powers, you'll add those exponents. The regular numbers out in front, just multiply them as normal. And that way, you'll get C as your answer for number 2. Now again, we haven't gone over number 1 yet. We haven't gone over number 1. We're going to come back to that one. So the first answer here is going to be C for number 2. Now, let's go ahead and check out number 3. So number 3, this is where we're dealing with powers to powers. So this might be a little confusing to some, but here's the idea. When you have a power to a power, you're going to go ahead and multiply the exponents now. That's the rule. When you have a power to a power, you multiply those exponents. So what it'll look like something like this. It'll look like this. We have a 3 out right there for the exponent, and so we will basically multiply those powers. So as a reminder, even though we don't see it, remember that on the 4, there is a power of 1. Remember, if you don't see an exponent on something, there is an exponent of 1. Don't forget that. And so with that 3, what's going to happen is we are going to basically multiply the 3 with that 4 to the power of 1, and then we're going to multiply the 3 with the exponent of 2. So again, it's like distribution, but you're distributing it to the exponents. And so with that said, what this is going to look like, let me bring this back. What this is going to look like is this. We'll have 4 to the power of 1 times 3. And then we also are going to have x to the power of 2 times 3. So that 3, that exponent of 3, is again essentially getting distributed in the exponents. Powers to powers, multiply the exponents. So with that said, I want you to understand why this is the case. All right, I want you to understand why this is the case. So first of all, the answer is going to be 4 to the power of 3, x to the power of 6. And 4 cubed, that's essentially like saying 4 times 4 times 4, right? Right. So one more time. 4 to the power of 3, that's saying 4 times 4 times 4. 4 times 4 is 16. 16 times 4, 64. And so that's what we'll have right there. 64x to the power of 6. But again, there's no point in me just saying all these things without actually showing you why. So here's why. When you take a look at a power to a power over there, let me just go ahead and kind of really show you what's going on. This is pretty interesting. So we have 4x squared, all of it to the power of 3. So remind ourselves, when we have a power, that means we're multiplying that number by itself that many times, right? X squared, x times x. 5 to the power of 3, 5 times 5 times 5. Here, we have a bunch of jargon there to the power of 3. And all that's going to mean is we're taking that, multiplying it by itself 3 times. So, with that said, this will turn into 4x squared times 4x squared times 4x squared. Now, if we follow the rule that we just learned previously, when it came to multiplying powers, we're literally just going to add those exponents, right? So, if you look over here, first and foremost, 4 times 4 times 4, that's already happening there. That happened. Now, if you're asking, why did we do 2 times 3 up here? Where did that come from? I got you. So where that came from is right here. Remember that when we have the same bases or same variables being multiplied, we add those exponents. And what we see here is 2 plus 2 plus 2. So if you're adding 2 to itself 3 times, what ends up happening is that's 2 times 3. And that's exactly what we see here, and that's why we end up getting 6. So powers to powers, multiply those exponents, giving us the correct answer here, B, 64x to the power of 6. And I'll go ahead and mark that right there. So let's go ahead and go to number 4, then number 5, and we're coming back to 1. I know I'm leaving number 1 for last because, again, I do want to make sure you're as confident and comfortable as possible. So I am coming back to number 1 after. But in the second practice set that I'll let you try out, I want you to go ahead and give it your all, picking whichever problem you want to try first. So we'll get there in a second. But here we go with number 4. Let me give myself the room I need. We have 2x cubed divided by 2x squared. So when it comes to dividing powers, what you'll do, handle the regular numbers as normal, simplify them, divide them, whatever you got to do. But when it comes to the actual powers or exponents, what you're going to do here is you will subtract those exponents. So think about it like this. There's a little pattern here. When you're adding powers, when you're multiplying powers, you add those exponents. When you're dividing powers, you subtract the exponents. And then we'll talk about powers of powers and roots in a second because there's some more good notes coming up there. But with that said, the 2's here are going to cancel out. 2 divided by 2 is going to cancel out. You're fine. Now, if you're asking, well, why are we going to subtract the exponents now? Because I heard the rule, but why are we subtracting? I got you. So what's happening here is, think about it like this. So the answer is going to be x to the power of 3 minus 2, which is x to the power of 1, or just x. Remember, any number is always to the power of 1. We don't need to write it out all the time. But let me show you how we actually get there. Because when you're dividing powers, what you're doing is you're canceling out exponents. Don't believe me? Watch this. X to the power of 3. What's that going to be? X to the power of 3. Let me use a different color here. X to the power of 3 is going to be x times x times x. Right? Right. Now, if we're taking a look at the denominator here, x squared, isn't x squared the same thing as x times x? Right? Fair enough. Now, what's going to happen when you are dividing the same things? You're going to cancel out what you can. And so x, goodbye. Then if I grab another color here, this x and that x are going to cancel out as well, leaving you with just x. So there it is. If you're dividing powers, you are subtracting the exponents or just canceling them out. So that's a good way to think about it if you want to build comfort here and confidence moving forward. It's all about understanding the whys before we start working for speed. So keep that in mind, my party people. And so up next, we're going to take the answer here. That's going to be C. There we are. We're all set. Now, going back here, there it is. That's C. Number 5, we're going to take care of number 5 real quick. Number 5 is pretty straightforward, actually. So what we have with number 5 is we are dealing with a negative exponent. So here, with this negative exponent, here's all you got to know. When you have a positive exponent, so let's go ahead and say x cubed, you're essentially saying you're multiplying that number right here 3 times. So x times x times x. Now, if you had x to the power of, let's say, -2, what that says is you are dividing the number that many times. A negative exponent tells you to divide. And so, if you have x to the power of -2, that's the same thing as writing 1 over x squared, because you're dividing that many times. And so a negative exponent, you can make it positive by basically switching it from the numerator to denominator or denominator to the numerator. Wherever it is, you just switch its position and you're fine. Because again, a negative exponent means you are dividing that number that many times. A positive exponent means you are multiplying that number that many times. So I hope that helps out, because this will make number 5 pretty easy. Because here's the thing. This is going to turn into x to the power of 7 in the denominator, because it was a -7 in the numerator. And so you're saying you're dividing x 7 times. Boom. But a lot of us may be asking, well, what happens to the 6? What happens to that? Well, what happens to the 6 is it stays exactly where it was. It stays exactly where it was right there. No issues, no problem. Because the idea here is that the 6 doesn't have a negative exponent. Right now, the 6 just has an exponent of 1 that we don't see. So remember, we are only moving the piece of the monomial. That's a monomial that's only one term together, but we're only moving the pieces that have negative exponents. If it already has a positive exponent, leave it in the numerator, leave it where it was. It doesn't change. It's only the negative pieces, the negative exponent pieces, that we're actually going to move. And so there it is. And that's why this was a pretty straightforward problem. That's why I like this one a lot. The answer here will be B. It'll be B. So with that said, let me go back over here. There's B. And now we're going to handle number 1 finally. And remember, after this one, we're going to go ahead and do another set where I'm going to give you some time to practice it, and then I'll go over the answers as well. So here we are with number 1. Let's go ahead and get to the elephant of the room. So we have a square root of 200x to the power of 4. So here's the thing. Remember how I said with powers of powers, you are multiplying those powers, right? When you're doing roots of powers, you are essentially dividing the exponents. So again, powers of powers, multiply the exponents. Roots of powers, divide the exponents. And so, what do we have here? We have a square root. Think about it. Square. What number does square sound like? Because when you have x squared, that's a power of 2. When you have a square root, that is a root of 2. So this right here that I'm going to write, you never really write it. It's always there, but you don't really write it. Kind of like how there's always a 1 in front of the x, or 1 in front of any number, right? There's always a 1, but we don't exactly write it all the time. There's a 2 for a square root, always there, but we just don't write it all the time, just for not being redundant and repetitive. So with that said, what we're going to do here is, again, divide those powers. So first off, I'm going to handle the x to the power of 4, and then I'm going to show you how to handle the 200. So with the x to the power of 4, essentially what you have is x to the power of 4 divided by 2. Now the reason I'm writing it like this is because this is a clean division. This is a clean division. 4 divided by 2 is 2. Right there. And so you can treat that as x squared, and we still have that square root. So again, x squared was able to come out, but we still have that 200 on the inside. So how are we supposed to handle that 200, right? What are we going to do now to handle this the right way? So what we're going to do here is understand that when it comes to square roots, only perfect squares can come out. Only perfect squares can come out. And so what does that mean? Well, 200 isn't exactly a perfect square. Remember, a square root means what number multiplied by itself gives you that number. So 200, not a perfect square, but is there a perfect square inside of it? Yes. Isn't 200 the same thing as 100 times 2? It is. 200 is the same thing as 100 times 2. So allow me to go ahead and rephrase this. Allow me to rephrase this here and change this right over there. We're going to change that 200. I'm going to erase 200. I'm going to replace it with 2 multiplied by 100. Now, why did I do that? The reason I did that is because, again, 100 is a perfect square. 100 can come out of that square root. 100 can come out. And so, with that said, what is the square root of 100? What multiplied by itself gives you 100? That's going to be 10. And so with that, nice and easy, the 10 will come out of the square root because it has to pass through the square root. So you got to go ahead and modify it. And so we'll end up having 10. Then the x squared is still there. And then we still have the square root. But what was left inside? What was left inside was the 2. So we have 10x squared with a square root of 2 being left behind. And that's why B is the answer for number 1. And so there's the first practice set, my party people. I'm hoping that I took you through a nice little warm-up where we went over all of those rules. Multiplying powers, dividing powers, powers of powers, roots of powers, and negative exponents. If you know those 5 rules, then you're in a really good spot to dominate these types of problems without much of an issue. These are problems where, again, you just need to learn the procedure and then just practice for speed as you keep going along. And so with that said, let's go ahead and look forward to the next practice set right over here. So I'm going to give you a second here to go ahead and pause the video. I want you to give these a shot. That way we can go over the work together and you can continue building confidence. And if you like the way that I'm teaching, if you want to join a free class or a free practice test, feel free to click the link in the description to get that done. But if you already have and you want to upgrade and you want more, remember that the All Access program is everything that my students need to pass the exam. That way they can get the jobs that they want. So I'll talk about that right after this next practice set if you're still interested. But let's go ahead, pause the video now, and give it a shot. And time, let's go. So with that said, my party people, we got practice set number 2. Let's go ahead and try this out. So I'm actually going to start right away with number 1. I'm going to start right away with number 1. So I know that's the elephant in the room, but we got this. The square root of 18p. So here's the thing. When it comes to the 18 is not a perfect square, but it does contain one. It definitely does. Because remember, this is the same thing as saying the square root of 9 times 2 times p. Now, why did I do that? Well, I did that because 9 is a perfect square. And 9 times 2 is 18. So I didn't, change anything here. I didn't write any false information. We have 9 times 2 is 18. So all I did was replace the 18 with 9 times 2. Now, the reason that that's useful is because 9 is a perfect square. And so we can take the square root. And so the square root of 9 is going to be 3. And then on the inside, we still have the square root of 2p. The 2 cannot come out because it's not a perfect square. And p can't come out either because p is not a perfect square. The exponent on p right now is 1. So if I were to try to take the square root, 1 divided by 2 is not clean. It's going to be 0.5 or 1/2, and it's not going to work. You want to maintain whole number exponents when you can, especially when it comes to taking the ASVAB. You'll see those answers as whole number exponents. But in case you don't, we can convert that to p to the power of 1 divided by 2. But for the sake of this problem, that's not the way that it's shown, and so that's all we can do. All we were able to do was bring out the 3, but the rest of it stays the same. And so we have 3 square root 2p, which is going to be b for the first answer. Now let's go ahead and take a look here at number 2. We're going ahead here, and we are multiplying powers. So I know that this is going to freak some people out, right? We're dealing with negative numbers. We don't like that all the time. That's not fun to do, right? But here's the idea. Follow the rules. That's it. Just follow the rules. That's all you got to do. So here, all we need to end up doing is, again, add those exponents. So what we have going on here we have a 1 in front of the x to the power of negative 1, right? That's always there. It's just a 1. So 1 times 3 is just going to be 3. But then we're going to have those exponents being added together. So we're going to have x to the power of negative 1 plus negative 2. So here's the thing. A negative 1 plus a negative 2, you're basically adding two negative numbers. So treat them as if they're positive, but keep the answer negative. 1 plus 2 is 3, but a negative 3. All right? If you're having trouble dealing with negatives, remember my program, it's there for you. I got your back. But there it is. Boom, that's going to be negative 3. Now, we're not done here because we actually have a result that has a negative exponent. And if we want to write this with positive exponents, we'll have to go ahead and flip it. And so remember, the 3 right here stays the same. That's going to stay. It's the x to the power of negative 3. That's what's going to flip. Because x to the power of negative 3, remember, that's saying, hey, we're dividing by x 3 times. And so that'll move to the denominator, x to the power of 3, to turn it positive. And that's why when we look at our answer choices, C will be the correct answer. So let's keep it moving here, my party people. We got number 3 happening right now. So number 3. So we have a power here to a power. Okay. Follow the rules. When you have a power to a power, multiply those exponents. And so what we're going to have here is remembering that the 4 has a power of 1 on it, and then the n has a power of negative 2. All you need to do again, take that power, multiply it with these exponents. And so what's going to happen here is 4 to the power of 1. We're going to multiply by negative 2. And then we're going to have n to the power of negative 2 times negative 2. So with that said, we're just going to go ahead and again, follow the rules and see where it leads us. We got this. And so with that, booyah, we have 4 times 1, or 4 to the power of 1 times negative 2. That'll end up being, let me just zoom out a little bit, 4 to the power of negative 2. N to the power of negative 2 times negative 2. A negative times a negative is a positive, right? Yeah. A negative times a negative is a positive, and 2 times 2 is 4. So right now what we have is 4 to the power of negative 2 times n to the power of 4. Now we're not quite done yet. We are not quite done yet. Because remember, a negative power means that we are dividing that number that many times. So we have 4 to the power of negative 2, which is going to be the same thing as keeping the n to the power of 4 up top, because it's positive, right? Exponent's positive. In the denominator, we're going to have 4 squared. Again, to make the exponent positive, you simply move it from where it was to where it wasn't. So it was up top, now we placed it in the denominator, on the bottom. But lastly, what is 4 squared? 4 squared, what that's going to be is 16. And so the final answer here will end up being n to the power of 4 divided by 16. That right here is our final answer. And that will give us answer choice what? That'll give us answer choice, let's go ahead and check it out, right there, B. Almost didn't see it, but there it is. I was looking at the A and C from up here. But there's number 3 here. There's number 3. Let's go ahead and check out number 4 here. Let's keep having some fun. So with number 4, we're looking at 2x cubed divided by 2x to the power of negative 1. Ooh, got a negative power in the exponent. I don't like that, right? No worries. First things first, before you actually do the division rule, you're not canceling those out because you have a negative exponent. So what you can do first is actually take care of business here. This x to the power of negative 1, you can actually move it, flip it first, and then proceed. So we'll still have the same exact problem, but it's just going to look a little different. It's just going to look a little different. Just like that. All we did was make sure that we have a positive exponent before we begin. That way we're not freaking out, right? So boom, there it is. And all we have to do now is, oh, look at that. We have a cancellation that happens right there. And then we also have, ooh, multiplying powers. When you multiply powers, what do you do again? Add those exponents and you're set. And so what we're going to have here, those are going to cancel again. So those are gone. And we just have x to the power of 3 plus 1, which is 4. And that's B. Right there. So again, my party people, this is how fun it can be. This is how fun it can be. All right. As long as we know the rules, it's just practice, practice, practice from there. And so before I get into number 5, I do want to remind you guys about the all access pass. So if you're not in the program already, This is how my students raise their scores. I know it's frustrating to deal with test anxiety. I know how frustrating it can be to have to wait to retake a test, especially if you're on your third try to wait 6 months. And the thing is, when it comes to formulas and equations and things like that, I know that a lot of the times you know the formulas, but maybe you just don't know how to actually use them confidently. And that's what I teach you. And there are 3 main things that you can use. This is the plan to ace the ASVAB. In the program, you can attend live classes and get every single one of the recordings, including every single one I've ever done. On top of that, you get to self-study and practice at your pace, on your schedule. You have 1,500 extra problems over the math, word knowledge, paragraph comprehension, and general science. And guess what? I just added an extra 1,000 problems in a worksheet or in worksheets. That way you can practice the basics with hundreds upon hundreds upon hundreds of problems. And with the math, a lot of these problems have video solutions to help you raise your score in the best way possible. But best of all, what good would a program be if you didn't have a mentor guiding you along the way? And that's why, lastly, over here, you get my support all the way until you pass. If you have questions about any problems you're working on, if you need me to help you make a customized study plan, all of that jazz, I got your back. And so live classes, all the practice you need, and a coach that has your back all the way until you pass, that's the All Access program. And it's for you, and I'd love for you to check it out by clicking the link in the description or clicking up here, as you'll see. But long story short, stop retaking it, lower your test anxiety, just pass the ASVAB and get the score you want so you can get the job you deserve. So lastly, let's go into number 5 here, my party people. Let's check it out. So number 5, we have 7x to the power of -5. Here we are. So 7x to the power of -5. Well, the 7 is going to stay exactly where it is. Because remember, that's a power of 1. You're good. But the x to the power of -5, how's that going to look? X to the power of -5, that's what's going to flip. So this right here, this is what's going to flip. So remember, everything is already over 1. Every number, every whatever you want to deal with is always going to be divided by 1. And so all we're doing now is, again, moving it from where it was to where it's not. So the 7 stays put, but it's the x to the power of -5 that gets flipped. And there it is right there. And so that's why our answer is going to be B right there. I believe we had a lot of B's for answers here, and that's okay. That's okay. The most important thing here is that we're learning. That way we can make progress in the right way. But one more time, everybody, as always, look, All Access Pass, if you enjoyed this video, make sure to like and subscribe and comment your favorite part, as always. But if you're looking to raise your score without all the stress, again, the program's for you. If you have any questions about it, or you want to learn more, or if you want to talk to me before you actually purchase, let me know. My number is 567-698-8867. Feel free to call me or text me. Again, I'm Anderson, your ASVAB coach, and I'm more than happy to answer any questions that you have. This is the most affordable ASVAB program out there. Costs $100 less than anywhere else, and it's also the best one out there. So if you have any questions, let me know, but I'm glad you watched to the end of the video. Let's ace the ASVAB, and I'll see you in the next video. Cheers. Hey, thanks for watching. Go ahead and smash that subscribe button up here. That way you can get more great content from us. Or text ASVAB to that number. That way you can join us for a free class and get a free mini course at the same time. And then look forward to the next video. That way you can continue crushing it and raising your score. Anderson, your ASVAB coach here. See you next time.